All right, we're going to finish off our last lesson of the exponents and logs unit. So in the previous lesson we did logs and exponents with base e. Today we're going to figure out how to do logs and exponents with a different base, whether it's base 2 or 4 or whatever. So if you remember from yesterday, we had the derivative of ln x. So if we had a ln x as our starting point, the derivative ended up being 1 over x, and we did that by a few different methods using implicit and using the limit laws for exponents, but what we need to remember is the two derivatives. So ln x becomes 1 over, e to the x stays the same. That's the only one that ever stays the same. So then we looked at what happens if we have something like e to the 4x. The derivative was keep it the same, so it's still e to the 4x, but then we would multiply it by 4. And for logs, works sort of the same. If I gave you something like ln of 3x squared, the derivative became 1 over 3x squared, but then we had to times it by the derivative of the brackets, which was 6x. So in this case, we could simplify it a little bit. We could go 6 divided by 3 is 2, and we could cancel out one of the x's to get 2 over x would be our final answer. Okay, so those were sort of the main ideas we did yesterday. So now today what we're going to do is figure out how do we do logs and exponents when it's not base e. So you can see at the bottom I've got log base 4, and I got exponents with the base 4. So let's start with So we'll start with the exponent, and we're going to try to figure out how to do that derivative. So similarly, you might remember in Math 30, if you had something like 2 to the x equals 5, right? We could either crisscross that, or we could just do log of both sides. So we could write it as log 2 to the x equals log base 5. And when we were writing it like that, typically we did log base 10. Right? That was a way of doing that. So from there, then we would bring that x down in front. So you'd write it as x log 2 equals log 5, and then we could divide those out. And then if we wanted to, we could even use that log law where we could write it as log base 2 of 5 like that. And that's kind of what we'd get if we would have done crisscross right off the start. But that process of doing logs on both sides is an important one. So what we're going to do today is we're going to use that same idea, except instead of doing logs on both sides, instead of doing a log of base 10, for example, we're going to do a log of base e. So what we're going to see is it doesn't change other than we just write it as ln. And then the rest of the process would be exactly the same. So when we get down to this step, it would be ln 5 divided by ln 2, and that would give you the exact same answer. So that's the approach we're going to do for these exponent questions. So if we have y equals 4 to the x, we're going to start by doing a ln of both sides. So we're just going to take the natural log on both sides of that equation. Then we're going to try to simplify it from there. So you can see the left side would stay the same. The right side, we'd bring the x down in front. So we'd have x ln 4. Let me clean that up a little bit. And then from there, we would solve it with implicit. So let's do the derivative of the left side. So ln y would be 1 over y, but then because it's a y, we need dy dx. And then on the right side, it looks confusing, and a lot of people would think we need to do product rule because we have two things being multiplied. But the ln 4 is just a decimal. So like think of it as being like ln 4 times x. And ln 4 as a decimal is 1.39, so it's just like 1.39 times x, so that derivative would just be 1.39, right? It's no different than having a derivative like 5x, and the derivative would be 5. So in this case, instead of using the decimal, let's just leave it as ln 4. So from there, if we solve for dy dx, we would bring the y to the other side, be y times ln 4, and instead of leaving it like that, let's go back to our original equation. Right? Our original equation was y equals 4 to the x, so let's just do a substitution to get rid of the y term. So if we plug that in for y, we would get 4 to the x times ln 4. And that's it. So you can see it's very similar to when we did regular exponents. So when we had e to the x, the derivative was e to the x. It stayed the same. So now if we have 4 to the x, The first part still stays the same, we still get 4 to the x, but now because it's base 4, we just have to remember to also multiply it by ln of that base number. And technically we could still do it with e to the x, right? If we did that for here, it'd be times ln e, but ln e is the same thing as log e of e, which is 1. You might remember that from Math 30, if you have log 5 of 5, that equals 1. So we don't technically need to write it for this version, we only need to write it when the base number is a non-e value. Alright, so let's do the logs next. So we'll kind of do the same thing. If you see our original equation is y equals log 4, we only know how to deal with exponents and logs if they're base e, so what we're going to do with this one is switch it by, change it to an exponent. So we switch it to 4 to the power of y equals x, right? Just do our normal kind of log to exponent conversion. Now, we just figured out in the last topic, we know how to do exponents when they're base 4, so this should be the same. The derivative now would be, keep it the same, but we need a ln 4 because of the base, and the derivative of the exponent being a y would also be dy dx. And then on the right side, derivative of x is just 1, so that's pretty simple. Rearrange this equation. We would just get 1 divided by 4 to the y ln 4. And again, we're going to substitute our 4 to the y out. So 4 to the y is the same thing as x, so that'll just be 1 over x times ln 4 on the bottom. Okay, so again, you can kind of see it's very similar to when we did regular lns. So if our original equation was ln x, the derivative was 1 over x, so you can see that part's the same. But because now it's a base 4, we have to tack on that ln 4 on the bottom. Well, I just want to show you quick a different way of doing this one. You could also, like we just looked at with when you do the ln of both sides, we could take y equals log 4 of x and rewrite it as a division. And then from there, the derivative is actually a little bit easier because it'd just be 1 over ln 4 times ln x. The 1 over ln 4 is just a coefficient, so that would stay the same. And then the derivative of ln x is 1 over x, so you can see we get the exact same answer if we do it that way. So the key thing to remember for logs is if it's ln, we just go 1 over. If it's some other value, so let's suppose I give you log base 3, we do the same thing, it'd be 1 over x, but then because it's base 3, we need to times it by ln 3 on the bottom, and that's the key thing to remember. Exponents, the ln 3 goes on the top, on the logs it would go on the bottom. So with our formulas, off your formula sheet, we see now we have our regular e, so our derivative stays the same. Our regular ln becomes 1 over, and then we multiply by the derivative of the brackets. So again, remember if I had something like e to the 3x squared, the derivative stays the same, but then we have to multiply by the derivative of that exponent. Okay, and the same thing worked for lns. So now today, the only thing that we're changing is the derivative ends up having a different base number of a, so we keep it the same, still times it by the derivative of the brackets, but we also have to times it by the ln of a. That should be an a, not a u. Okay, and then for logs, the same thing again, because it's base a, we just have to do that one extra step of dividing by ln a. And that's it. So it's not much of a difference from what we did before, we just are adding that one extra little wrinkle to it. So let's do a few examples. So here's an exponent question of base 3. So again, remember when you're dealing with exponents, keep them the same. So it should be 3 to the 2x times it by the derivative of the power, which would be 2 in this case. And then because it's base 3, we also have to times it by the ln of that base number. And that would be our final answer. We can leave it like that. The order doesn't matter. We could, if we wanted to, we could write the... oops, my pen's not working. We could write it in different order. I'll leave this one. It doesn't seem to be working properly. So because they're all being multiplied, flip it around however you'd like. Okay, here's another one where it's a log this time. So again, follow your log rules. So the first step would be go 1 over. And you could put brackets around here if you want. That might make it a little bit easier. So go 1 divided by the brackets, times it by the derivative of the brackets, which is 6x in this case. And because we have ln 3, our base 3, remember we got to divide by ln 3. So some people like to write it like this, where you kind of multiply all of your different steps. And then from here now we just simplify. So if we put all that together, we could cancel out of the 6 and 3, and we could cancel one of the x's. So if we simplify that, we would have just a 2 left over on top, and just a single x ln 3 on the bottom. And that's as far as we can go with that one. So just remember to do that one extra step of doing the ln of the base number. Other than that, everything else follows the same rules as before. So let's do a couple questions now where we have product rule or chain rule or something like that. So any of these certain situations, we still have to follow our regular product rule and chain rule steps. So for this one, think of it as f times g. So let's deal with that first. So if f is e to the x, the derivative is the exact same thing, right? Doesn't change when we do the derivatives. And then for the second part, g is 3 to the sine x, so we got base that's not at e, and we have trig as our exponent, but that shouldn't matter. First step, keep it the same, so 3 to the sine x, times the derivative of the exponent, which would be cos x, times ln of 3, because it's not at e. And that's it. So from there, use our normal product rule steps. So let's multiply those two, so it'd be e to the x times 3 to the sine x for the first part. Second part, let's multiply those ones, so it's e to the x times 3 to the sine x times cos x times ln 3. And we can stop there if we want, or we can see we have a couple of common factors, so let's take that out to clean it up a little bit. So let's take out an e to the x and 3 to the sine x, and we'd have 1 plus cos x ln 3 left over. And that's good enough for that one. Alright, the last example I got for you, similar kind of question, except you can see the product rule this time now is inside the brackets. So that's going to change things slightly. So when we're dealing with derivatives like this, still work outside in. So let's take care of the log part first. So the log would turn into 1 divided by, so you'd have 1 over 4x cos x. Okay, that takes care of that. We got the 3, so let's do a 1 over ln 3 to take care of that base number. So now the rest of it is we got to multiply by the derivative of the brackets. And this is where the derivative of the brackets gets a little weird because it's a product rule. So let's follow our product rule steps again. So let's call the 4xf. So that derivative is 4. And let's call cos x our g. So that derivative is negative sine. So now we should be able to fill that into our brackets. So let's do our normal 2 first. So we'd have 4 cos x. And then we would add the other 2, which would be negative 4x sine x. Okay, so that's it for our derivative. So now let's just simplify it a little bit. Let's take out a 4 on the top. So we'd have 4 times cos x minus x sine x. And let's put our bottom stuff together. So you'd have 4x cos x ln 3. So you can see the 4's will cancel. That makes it fairly nice. And we could stop there, but we could also maybe do a little bit of other adjusting. We could split these fractions apart. So we could go cos x minus sine x sine x on the top. And let's put each of them over the denominator separately. Doesn't really matter if we do this or not, but it in this case simplifies things a little bit better. So you can see on the left fraction the cos x's cancel, so that would just give us 1 over x ln 3. And then for the second fraction we can cancel the x's, and the sine over the cosine, we can combine those to be tan using a trig identity all over the ln 3. So we could stop there, or I can see one more little, if we want to factor out a ln 3 on the bottom, we could even write it as 1 over ln 3, and then we'd have 1 over x minus tan x. And that would be pretty much as far as we could go with that one. So when you're dealing with these, remember to follow your product rule, chain rule, quotient rule, all those kind of things first, and then just deal with your logs or trig or exponents or whatever it happens to be as part of those rules. Everything else would stay the same. So if you did a combo, do a product chain combo would be fine. Implicit, we looked at a couple already, would be the same. If you were doing second derivatives, third derivatives, same sort of logic applies. Just keep going with whatever your final answer would be. So that's it. We'll stop there. You should be able to finish off the last worksheet. And that's it for this unit. We'll move on to graphing in the next unit.